All right, this is the sklearn review portion of the midterm. This video will be quite a bit shorter because, like I said, this is a lot less actual content on the midterm than the pandas version was. So let's go ahead and dig in. So just like I already reviewed, I've got the exact same notebook that we used for the telco customer churn and for the previous review. So I've already loaded the data. I've already got the X and the Y, right? So I've already got X, I've already got Y, I've already selected the continuous and the categorical variables. And in this case, I've already scaled it, although you'll have to do that yourself on the midterm. This data set's just a little different than that one. So let's scroll all the way down to the bottom, and I've got two questions. Scale the X categorical data set and use X and Y provided to perform a train test split, then train a decision tree and score the model. So you can see here I've got three things imported. I've got the train test split, I've got the standard scalar, and I've got the decision tree classifier. So let's go ahead and use those. So for question one, I have to actually say scalar equals standard scalar. Right there, I've got to initialize it like we've talked about. And then if I look at scalar, if I run that, and then now down here I look at the scalar dot, you can see I've got fit, and if we remember, that's where the scalar learns from the data set, right? It looks at the data set and it collects the averages, it collects the sum, all that kind of good stuff, right? So it goes and it learns from the data set. I've also got a transform where it takes what it's learned with the fit and it applies to the data set. It actually does the scaling or it does the imputing depending on the thing you're doing. I can do both in one with this fit underscore transform. So in this case, I'm going to do scalar fit underscore transform. Because I can't actually scale the same data set again, what I'm going to do is I'm going to go data categorical. Oops, what did I do? Categorical is not defined. Well, let me go up here and run this all again. Run that, run that, run that, run that. So I've got, oops, I'm sorry, continuous. That's what I wanted to do. So I've got X continuous. So continuous are two columns. They're the continuous data columns. There we go. That's right. So what I get back is this data set where it's got two columns and they're scaled. If I look at the data that I just scaled, it looks like this right here, data brackets continuous. And you can see here I get two columns back. Here you can see that they're scaled properly for my machine learning model. And that's actually all I had to do. I had to take the scalar, I had to initialize it, and then I had to do a fit transform on the continuous data. Yeah, that's why. That's right. Okay, on the continuous data set. All right, now let's do the actual meatier part of it. So I've got to take the X and Y and I've got to do a train test split. Let's actually make a note of what I did here. Right there. Let's put a new one. Let's do comment. There we go. All right, good. So I scaled the X continuous data set. I took the data, the continuous columns from it, and I scaled them. And I don't need that anymore. So let's actually do number two right there. So what I've got to do is copy number two. Let's make a comment out of it. There we go. Okay, so I've got to use the X and Y provided above. So I've already got an X, I've already got a Y. Let's do a train test split. X train, X test, Y train, Y test equals train test split, X, Y. That's all I have to do. So now I've got a training set, a test set, and I've got both. So if I look at X train.shape, I've got 5,282 records for X train, and Y train has 5282. Looks good. X says shape has 1,761. Okay, very good. So I've already done the train test split, so that's done. Now I have to train a decision tree classifier. So I've already imported a decision tree classifier right here. So what I need to do is I need to take it and I need to initialize it just like I did the scalar. So you can call it whatever you want. In this case, I'm going to call it CLF for classifier equals decision tree classifier. Now, if we think back, there are all these parameters I could set. If I hit tab in here, I could set the weight, the depth, the features, all of this stuff, but I don't need to. Wasn't told to set any of that, so I don't need to set any of that, so I'm not going to. So what I'm going to do now is I'm going to go ahead and hit enter, and I'm going to take the classifier dot fit. So if you remember classifiers, well, let's just go ahead and run that. Let's do enter, and now I've got clf dot tab, and if you remember, I've got all these different things, but I can fit a classifier just like I could that scalar that I did earlier. I can't actually transform with these. These don't really do any transforming, but they do predict and they do score. And so let's go ahead and do a fit. And so just like the scalar learned from the data set, whenever I fit it on the preprocessed data set, this will learn from the training data. So I've got to do clf.fit xtrain, ytrain. And now I have a decision tree classifier. It's got all this stuff that I didn't set. Those are all the defaults that I could have set up here, but I just left alone. So now I've got a trained classifier. Now let's go ahead and score the model. So what I'm going to do is clf.score. So there, right there, clf.score on the x test, y test. And there we go. I've got a 61.3855% accuracy. If I wanted to do that manually, what I would do is from sklearn. If I wanted to do that manually, I'll do dot metrics import accuracy score. So I'd import the accuracy score, and I would actually need to make a prediction. So I'd do what's called y hat, which are my predictions, clf.predict in this case on my x test. And so this y hat right here are the predictions that it made for the test data. So this y hat's dot shape should be the exact same as the actual y test shape, and it is. So now what I need to do is use accuracy score to evaluate how often I was wrong. So I'll do y test y hat. And in this case, I'm 61.38557. There you go. See, so it's the exact same accuracy score, but this way I could do it by hand. You would also do this because there are a number of different scores, like the F1 score right there, that I could also have done. And F1 is a little bit different. It's like a combination of precision and recall. It makes more sense usually for more classes. Anyway, so I could do this right here, and it would score it just as well. And this is how I do it manually. But this clf.score works just fine. And so what I've demonstrated here is, just like with the midterm, I have an x and a y. They're already prepared. But if I was asked to exercise the scalar on a specific subset of columns, I would do it right here, where I initialize the scalar using the standard scalar that's already imported. I do a fit transform. And if I actually wanted to capture this data, I would have actually done it this way. In this case, now I would have actually saved that data set out. You saw before I actually just returned it, right? In this case, I've created a new data set of X processed, and I've actually stored it as an array. And so previously I wasn't saving it. If I wanted to, this is exactly how I'd do it. I'd create a new data set by calling scalar fit transform, where it learns from the data, and it transforms the data in one step on these two continuous columns of my data frame. And you can see here now I have a new array that only has those two columns scaled. I've taken the x and the y that were already provided. I did a train test split. I got an x train and x test, a y train and test. I initialized my decision tree classifier. I fit my classifier on the training data, and then I scored it on the test data. If I wanted to do my own scoring metric, I could import one from the sklearn metrics. I could make some predictions from the test data. So I take my classifier that's already trained. I've already done the fit, and I use the predict. So you can see here I've done a fit, I did a score. Now I'm doing a third thing. I'm doing a predict. And this just returns the actual predictions the model is making for the test data. Now I can compare the test data, the actual one, right, because I know these answers, with the guesses that my model has made and get a score out of it. I could get the accuracy score like I did before. In this case, I'm doing a different metric called the F1 score. And so that's about it as far as the content for scikit-learn that'll be relevant. Getting a model that's already imported, fitting it, and making predictions and assessing the accuracy of the model.